and also is it what's the screen show there? The screen or me?
I see both of you.
Okay, so perfect. All right, so go ahead. So just real quick, for the Amazon raffle, you do need to register through that one site. I sent out the link earlier. So if you haven't and you have a laptop, do it now. If not, we'll have a computer where you can do it as well. So just keep that in mind. Yeah. The Kindle. Yes. Yes. You also get the other discount. So do you want to go ahead and hit record? Or, again, second time? Are you recording now? Oh, well, what do you know? There we go. So without further ado, here's Len Grimmer, and he's going to talk to us about high availability MySQL. Thank you.
So, now I talk by a live person in front of you. Welcome, everyone. You can't hear me. The mic is on, but I have a very weak voice, so to say. Hey, let's see if we can move this up a bit. That wasn't me? No, okay. I don't beep. Okay, I'll try to speak up, but remind me if I'm getting lower with my voice again. So, wow, that's a big crowd. I'm pretty excited to be here. Thanks for having me. Topic of this talk is going to be MySQL high availability solutions, and what I'd like to do is give you an overview of how you can make a MySQL server instance more robust and more more available if some of the systems go down. Let me start with a quick introduction of myself. My first contact with open source software was in 1995 during my studies in the university. This is where I first learned about Linux and all the exciting things that you can do with it. I've been using Linux on my desktop exclusively since then, which kind of led me to working for a company that is related with Linux. I was a distribution engineer at SUSE from 1998 until 2002. That was before they got acquired by Novell. One of my first tasks there was to add MySQL to the distribution that didn't exist before, and one of you needs to switch off your phone. It's okay. Back then, MySQL was not available under the GPL. They still had their own homegrown or homebrewn license, which basically made it impossible to include it on the distribution based on the terms they have set up. So I got in contact with these guys, Monty and David, the founders of the company. We exchanged some email, and I kind of asked them, okay, what can we do to get MySQL on SUSE Linux, since I really wanted to have it on there. And the deal that we struck over email was that SUSE is allowed to include MySQL, and in return we sent them 5 packaged boxes of the distribution each time we make a new release. So that was a pretty cool deal. And so since then, MySQL is available on this distribution. Actually, SUSE was the first of the Linux distributors that shipped MySQL as part of their package. So I've been in contact with these guys very early on, which, we stayed in contact every time there was a new release. We were talking about what needs to be fixed. I met Monty and David at numerous conferences all across the world. They were giving talks about MySQL. I was giving talks about SUSE Linux, so we bumped into each other quite a lot. And during some random email discussion, I kind of jokingly asked if they would have a need for a guy like me, and boom, 2 months later, I joined MySQL as a release engineer. So my first task was offloading Monty from the task of building the MySQL releases. So the developers were hacking on the code, and at some point, it was time to make a new release. And then when I got into gear, I started the builds, compiling MySQL on all the various platforms, doing the packaging, publishing and uploading the things, sending out the release announcements. All these things that relate to release engineering were in my lab back then. I also started getting engaged with the MySQL community on our mailing list and all the other available forums that we had. So at some point, I realized that this is what I'd like to do more, and I went to doing community relations exclusively, and this is what I still do. Back when we were an independent company, the community relations team actually reported to Martin Mikos, the CEO, directly, so it was always a very important role inside of the company. So we didn't report to marketing or were part of engineering. We really were independent from all of these groups, sometimes even with a different agenda, especially with marketing. And we, of course, had contact with all these groups. As the community team, you really have to pull strings into all these various directions. You get feedback from the users, from your community, that you have to then trickle into the engineering organization to let them know what needs to be fixed, what the focus of the product should be. You talk with the marketing folks about how the messaging to the community should look like. Product management needs to be advised on how the community expects things to be done. So it's a very exciting job, and I still enjoy doing it, even though I switched companies 2 times in the meanwhile. You probably all know the story of MySQL and how we got acquired by Sun and how Sun in turn got acquired by Oracle. So I'm now an Oracle employee by business card and, well, kind of still a MySQLer by heart, I guess. So this is what I am, who I am. I'm here in the Bay Area for the same event that Sarah was talking about, the IOUC Summit, as in my role as the MySQL community relations contact for the EMEA region. So this meeting was really a meetup of all the leaders and presidents of Oracle user groups worldwide, not just the US. And what struck me as very interesting is that all of these Oracle user groups do have a lot of interest in MySQL. Their users and the members already use MySQL somewhere in their data centers already. And now that MySQL is part of Oracle, they are not shy anymore to actually talk about it. So in a way, MySQL has become a bit more serious with this backing. And as it's probably obvious with the latest release of MySQL 5, Oracle is not out to kill MySQL in any way, quite the contrary. MySQL definitely changed and mature over time. This is what a big company brings with it. And I think some of these changes are certainly for the better. I mean, a small startup has different focus and different requirements for a product than a company like Oracle, who definitely realized that MySQL is not competing with a big database. And MySQL serves a completely different need and audience, and this is where MySQL is going to be improved for in the future. So we're not trying to become a replacement or a competition to the Oracle database, but we are going to make sure that MySQL will continue to be better for the use case that you are all using it for. And so we are now much better suited to really address the needs and the requirements of where MySQL is being used today. That said, let me give you a short agenda. I start with a little background about MySQL high availability concepts, then I'll try to introduce the various building blocks of what you should take a look at if you want to create a high available MySQL setup. And this is an introductory talk. I'm not going to go into the gory details on how to actually set this up. Each of these components are quite complex, with the exception of MySQL replication maybe. So it also requires that you have to look into what your particular needs are. High availability usually isn't something that you can get off the shelf and it suits your needs. You have to really customize it and make sure it fits your personal requirements and what you need to get configured in your system. MySQL cluster, pacemaker, all these are tools that I'm going to talk about. So let's take a look at what you probably know. So we have a server here, a PC. You have MySQL running over there. You have your local hard disk drive. And your client, either your web app or an external application, it talks to the MySQL server using SQL statements. These can come either through the wire, so over TCP/IP, or even on a local socket coming from the same machine. The MySQL server takes your statements and performs the required action and then stores the data on disk on your file system and returns the result sets to you. So what happens if this machine crashes? Well, you're screwed. You don't have any replacement. You don't have any backup. the client can't talk to the server anymore. So something needs to be done about that, particularly if that client is a web app that serves 100,000 people that are waiting to get their order placed into a form. So why do I need high availability or HA? What you can really be sure of, something can and it will fail at some point. And according to Murphy, it will always fail in the time that you're not expecting it to be. And, well, if you're a web shop, there isn't really an ideal time because somewhere over the globe somebody is awake and wants to do a purchase. So downtime is usually not an option. But it's not only necessary to avoid grave failures in hardware or software. Sometimes you just want to be able to make an update of the operating system, or there's a security problem with MySQL and you need to update. So for service maintenance, you need to be able to have a way to keep your system up and running but still be able to perform such maintenance tasks. And yes, I've already mentioned it, downtime is expensive, and depending on the role in your company, you either get fired or you go bankrupt if something like this happens. So keep it in mind, downtime can be significant. And also, if you are just starting from scratch and you're building up your infrastructure and you're working on developing a new system, try to consider high availability as part of your entire setup from the very beginning. It's usually quite painful to add this to an already existing and running system without introducing any downtime. If you start with having high availability in mind from the beginning, you're much better off than trying to plump this in at a later point in time. So the aim of high availability is to eliminate the so-called SPOF, the single point of failure. And the single point of failure can be quite a wide range of things. Things that definitely fail at some point is everything that is moving and spinning, like hard disk fans, spinning rust, like hard disks. They have a mean time between failures. And especially under extreme circumstances like high temperature, these end-of-life situations tend to get reached much faster than you think. CPU fans are always cheap or too cheap, and they start to fail. But not always hardware can fail. Your application can crash. There's a bug, and one of the services goes down, and your website still fails and is not reachable. Linux, for example, has this nice tendency to completely come to a grinding halt when you run out of memory. Or if you go heavily into swap, all of a sudden your system is so busy with itself that it's not servicing any request anymore. And the only solution for that usually is you have to reboot if you can still enter the shutdown command. And Linux can really get itself into a state where it's not reacting to anything anymore. And in that case, you just have to flip the switch, which then might lead to other problems and you want to get back up on your feet again. Other operating systems handle this a bit more gracefully. Or, well, the classical case that the cleaner trips over the cable and the network cable of your server is out, no connection. What happens? Power supplies are always good for fun, so there are lots of sources that can become the single point of failure that you should take a look at and need to be aware of. And this really is something that only you can identify. You have to go through your configuration, your system, your environment, and take a look at, okay, where are the crucial parts? Which are the things where I might want to have a replacement somewhere on a shelf, or even better in a hot standby mode, ready to be acting as the replacement for the active system. And with computers and servers, what you usually do is you create a cluster. A high available cluster means you provide redundancy of hardware and the data that you want to store in it. In that case, you have a backup system or more of them that can take over in case that your primary system goes down. In the case that I'm talking about, what you usually do is you have a so-called virtual IP address. This is the IP address that is known to the other services and applications to talk with this particular server. But this virtual IP address can move between different physical hardware machines. So the application doesn't really care. It's always talking to the same IP address, and it doesn't realize that the hardware and the system behind it has been replaced because the original one went down in the meanwhile. And yeah, you have to ensure that the data that you want to make available is also in an integer state, or is is not corrupted by the failover or by the failure that has occurred. And even though it's tempting, a high availability cluster is not designed to replace any performance tuning measurements that you might want to also make. So a high available HA cluster is something different from a high performance cluster. Sometimes you can use it for both purposes, but something that you have to keep in mind, if you design your system that two machines are constantly serving your load, because, well, who wants to have a system just being there running idle? We can make use of this because we currently have such a spike in load. Let's use the hot spare for this. Cool. And then the primary system fails, and all of a sudden the load that you've gotten used to had to be served from that single remaining box. And then you run into the next problem because it will get saturated and fall on its feet or over its feet. So high availability and scale out are two different things, and both need to be kept in consideration, of course. You probably have seen this slide before, if my clicker works. The level of availability is usually given in a percentage, uptime per year, and the magical 5 nines is when you have only around 5 minutes of downtime per year. And that little curve here also shows the cost that is usually involved with getting there. So the question that you should be asking yourself, do I need 5 nines, or is it fine if my system is available for, well, at least less than an hour per year? Does it make sense? No, or can it go down for less than an hour per year? Sorry. Yeah, well, I'm from Hamburg, Germany, so English is not my native language. If I sometimes speak weird stuff, just wave your hand and tell me that I'm speaking rubbish. And in general, if you have a question or a comment, or if you have something to contribute to what I'm talking about based out of personal experiences, raise your hand and we can take it along right away. I prefer an open dialogue much more than an upfront presentation like this. So please feel invited to engage if you feel.
Well,
yes.
Actually,
there you go.
Sorry, silly question, but could you say something about you conceptualize the difference between high availability and high performance?
Yes.
Can you state it again? I just want to have this concept clear.
Okay.
Very
So
clear.
you want to get an explanation of the difference between high availability and high performance?
Yeah, if you repeat exactly what
Sure.
you say, I cannot get a lot.
Okay, consider that you have a system that you want to make highly available. In order to do this, you need redundancy, maybe in the case of a second server. So your application runs on your primary server. The second server is a hot standby. It's doing nothing because it just waits for the case that the primary goes down and then it takes over. So it makes sure that the data is always being synchronized and it's ready to start at any time. Then your boss comes in and says, hey, our website is getting so much load. We need more power. Isn't there this second box? Can't we use that to serve some parts of the load? So you enable the second box and you start serving requests from there. So now your application is distributed on 2 machines and the load goes down. Cool. And then the primary node crashes. So all of a sudden, the load from this service and the additional load that you have put on the other box goes to one system. And yes?
So isn't it really full utilization as opposed to high performance? Because you can still get high performance, but you just can't fully utilize everything in case you need to.
Yeah, that could be doable. So you could say, yes, we are using both systems, but we're just utilizing them to 50% each. But where's the difference? 2 times 50% to 1 times 100%?
No, but what I'm saying is you can still optimize for high performance, but it doesn't necessarily mean in order to have some level of buffer, you need to have reduced utilization.
Right.
You're not fully utilizing all of your service.
Yeah, you might get away with it, sure. All I'm trying to say is don't assume that your high availability system should be serving for the load distribution or to increase the performance. This should really be done on dedicated machines that can also be replaced with failover mechanisms.
Right. So in summary, we can say high availability is redundancy, high performance is load to maneuver between the two of the
Right.
is important. We have to keep in mind. All right.
Okay. So, yeah, nice curve. Rules of high availability. I put these in front. I usually had this as the last slide, and then I realized I run out of time and this slide never shows up. So I start with it here. Again, prepare for failure. It will happen at some point. If your service is valuable and you depend on it, make sure that it's always up, or that you can provide at least a reduced level of service and you're not completely offline in any case. And also try to identify what is really important that needs to be available. Is it the entire website with everything, just parts of it? Most of the really popular websites usually degrade in a graceful way, so that parts of the service is still available. Let's say you have a video or a picture uploading site. The part that still serves pictures is still up, but the part where you upload pictures might be down for a moment because this part just has a downtime. So try to identify if you have any options for implementing it in this direction in order to not having to make everything fully redundant. And yeah, keep it simple, stupid. The case of a downtime when something has crashed is usually when you have the highest stress and you need to get your system up and running as fast as possible. If you first have to read a 50-page manual to follow up and figure out how the system gets back up, this is likely going to cause you a lot of stress. So make sure to keep it easy and simple. And it's tempting to start adding everything to the high availability system. Hey, the mail server, cool, let's put it into in here as well. And the file server, yeah, we want to make sure that this is highly available too. So you have a very complex setup that all of a sudden serves way too many purposes and it's hard to figure out what happened. Or the administrator is on vacation or has left the company. So the more complex the system is, the harder it really is to get it up on its feet in case there is a failure. And also, as much as possible, automate this whole thing, create scripts, reduce the manual intervention as much as you can to make sure it's repeatable and has been tested. So the last part really is the most important one. There's no point in setting something up that is highly available that you haven't tested at all, because you just trust, yeah, it'll work. Also, if you have made changes to the system, test if it still fails over. If you have installed a new package, if you have made an upgrade of something, it may have changed something underneath that you're not aware of. Maybe the system doesn't boot up anymore. So even though there's always a little risk involved, the more testing you do, the less harmful is the fire drill. If it really goes down and it doesn't come back up again. Because then it's under your control. You're in front of the system. You can make the change. You can see if it comes back up properly or not. Murphy strikes again. Usually, if a failure occurs, you're not around because you're just asleep. It's 4 a.m. And then you're back in the data center, half asleep, and the system doesn't come up because you made a mistake. So that's something to avoid if you tested it before. Parts of an HA system. Heartbeat. That's the process or the application that kind of pings a service or an application or an entire system if it's still alive. Or several systems talk to each other and ensure that they're all still available, that the data that they are returning makes sense and it's not garbage. These are usually done through some kind of heart-beating system. You can either create this by yourself. The easiest way to check if a web server is up, you create a little shell script that runs wget for a web